Good morning, good afternoon, depending on where you are, and welcome to this webinar digital session on the topic of going beyond observability for Spark applications and Databricks environments. My name is Kwok, and I'm from Unravel, and I'm here joined by our Unravel expert. You may know him as Chris Santiago, who's our Solution Engineering Director. Hello, Chris, again. How are you?
Hey, Kwok. Long time no talk.
Before we start, here are some quick housekeeping rules. If you do have any questions, feel free to pop them into the question box below the player. Type in your question, and we'll answer them at the end of the session. Or if you are watching on demand, we'll answer them by email reply. This webinar is available instantly on demand, so if you do have to drop off, feel free to come back to this page and listen at your leisure. Let us know what you think of the session by rating the webinar. If there's any topics you'd like to hear from, maybe it's go deeper in Databricks. You want to learn more about that, or do we support other stuff like Google and Amazon and Azure and things like that? If you'd like to learn more about, definitely give us a shout on the comments box. Right, without any further ado, I'm going to hand over to Chris now, who will then take you through the session. Thank you.
Thanks, Kwok. Just let me know if you guys, or Kwok, if you can see my
screen.
I
can see.
All right. Actually, let me go and take it a step further. Let's go full screen here. So, hey, folks, just in case you don't know my face, here it is, nice and big. My name is Chris Santiago. I am the Global Director of our Solutions Engineering group here at Unravel Data. If you're not familiar with Solutions Engineering, we are the face to, really showing value with customers in terms of, what are some of the things that you can do with a tool like Unravel, and really make an impact in your organization. Quick background on myself, if this is your first time meeting me. Been with Unravel Data for a little over 3 years now, and it's been an interesting journey, working with folks, particularly on big data, modern data stacks, and we're at a crossroads right now. We see a lot of folks that are doing, Spark is a very, very popular engine out there. There's a lot of interesting use cases that you can do with Spark, and companies like Databricks have really taken on, and the tech has really resonated with the user community. And so, some of the challenges that folks face when when they're dealing with Databricks, there's a multitude of things, right? I'm going to focus my discussion on just an observability standpoint for your Spark applications in your Databricks environments. And so what that means is, hey, I'm responsible for writing these Databricks jobs, these Spark jobs, making sure that we're meeting our SLAs, so on and so forth. What are my options that I have today out of the box? What are my additional options that I may have, maybe with some cloud native tooling, maybe with some third-party observability tools that are out in the market. And I'll kind of walk through some of this stuff. May resonate for some of you folks. Maybe you're using it today. Maybe it may be new to you. And so that, there'd be a good learning experience from there. But, I do want to provide all the options that you guys have, at your arsenal, based on just out of the box, what you have today. Let's maximize that. But, if we want to go beyond that, let's start looking at some other observability tools like Unravel Data to take you to that next step. So, why are you here? As a Databricks developer, there's a lot of things that you're responsible for, right? Like, why did my job fail? I've got this job, it ran perfectly yesterday. Now it's running 2 times slower today. Why is it running slow? With Databricks, it's a great service where it kind of abstracts away a lot of like the infrastructure related items that you would typically do if you were going to spin up like a Spark cluster. But now you have to have some kind of level of insight on, hey, what do I got to do from an infrastructure perspective? I've got a plethora of instance types to select for my driver and workers. Which one is going to make sense to me? Should I be using auto scaling? Is this going to, really help me contain costs, or, could this actually, ruin things, right? Or maybe it's something where maybe out of your control, right? Just with Databricks, it is a solution as a service, right? And hey, so no offense to the cloud vendors that are out there, they do a great job, but sometimes it could be network related from an AWS perspective, Azure, GCP. And hey, if there is an issue there, maybe there was a downtime in a specific region, wouldn't you like to know, right? All of these things, really come into play. And I can feel for you guys. So I come from a development background. Before I started my journey as a solutions engineering, director, I was in the trenches, right? And working with a lot of distributed systems, like starting in Hadoop and then going into Spark, lots of things, right? And it's very, very complex. So I can definitely relate with you guys. Just a couple of things that's probably top of mind. Hey, is my job configured properly? Like, did I select the number of nodes correct? Did I select the instance types? Am I over? Am I under? Here's my Spark code. I see that there's a new runtime. Is my code compatible? Like, there's a lot of things that's going on from a job perspective. Another thing to be mindful of is, hey, did I allocate my job for resource efficiency, right? In this pay-as-you-go world where you're being charged by DBUs, it's not like how it was a couple years back where I've got a Spark cluster, there's a finite set of nodes that I have, available in my arsenal. If my jobs continue to fail, it's just wasted time. But, in this pay-as-you-go world, you got to be mindful of that, right? And so a couple of things that you may be thinking about in terms of just maximizing your resource efficiency, like, hey, am I using RDDs? Should I be putting all the stuff in memory? Should I be, reading the stuff from disk? What am I, how does that impact network-related issues? Again, that auto-scaling, hey, is this going to be good for me? I'll give you the quick cliff notes. Auto-scaling may not be the best thing for you, both from just making sure that your job is running stable, but then also, there could be some adverse effects if not done correctly. And then also too is like from a cost perspective, there are some reserved instances. How do I know how much I should be reserving? And when I'm going to negotiations with Databricks, with the cloud vendors, how do I know? And the more data that you have, obviously is gonna help your case there. But these are things that you need to start thinking about, right? Or is it just really my code itself? Am I a rockstar Spark Scala developer? Python developer? There's that layer of complexity too, right? In terms of like, did I configure my Spark application correctly? Sometimes it isn't. Maybe your code could be rock solid, but your configurations could be off. And then even just from the code itself, like just the logic itself, like, are you dealing with data skew? In distributed environments like Spark, you want to make sure you have, equal amount of distribution across all of the, instance types, your drivers and your workers. And obviously if there's, workers that are working a lot harder than the others, or maybe the driver is doing all the work and the workers aren't doing anything, obviously that has impact on your performance and stability of your jobs. And then obviously resource imbalances too. So yes, in a nutshell, Databricks jobs, complex, things that to think about, left unchecked. This takes away time from developing, right? It's not in the best interest of a Databricks DevOps developer to be spending their time troubleshooting. They should be writing quality code, whatever it's like, the next best-selling or machine learning algorithm that's going to really, help, your organization. Like, you should be spending your time on that, right? Instead of, why did this job fail? Kind of like anytime we talk about just making sure that we're allocating resources, we want to make sure that we're doing it in a properly allocated way, right? We don't want to over allocate because obviously that's wasted money. We don't want to under allocate because that could have adverse effects in terms of stability and runtime. Missed SLAs, this is always a big one, especially for folks that are using Databricks. Maybe you're using job clusters, and you need to make sure that, maybe this is a data set that an external customer is going to be using, and you want to make sure that you're making it, you're meeting your SLAs. And if something misses, obviously there's a problem from that standpoint, right? So you want to make sure that any job that you spin up is, you have the proper tools to kind of give you the observability to troubleshoot this, quickly troubleshoot this and get to the next thing. And then finally, one of the things we want to avoid is just failure in general, right? Failure with the tech stack, failure with the project that you're using, like a service like Databricks on. And that's, ultimately what we want to avoid. And so the good news is you have some options, right? So, you have out of the box monitoring tools here that we'll go through real quickly here. But you do have some options to give you some observability on what's going on, both from a job perspective, zooming out to a pipeline perspective, and then overall your Databricks Spark estate, right? So always good to start off with a good old Databricks console, Databricks UI. And so, very, very useful, just gives you a nice clean interface of all the types of jobs, whether they're all-purpose clusters, job clusters, what's the status, what drivers, types, the worker types, all that good stuff. Very, very good place to just have a good understanding of what's going on. Not the greatest if you're trying to understand historical purposes. So there is a point in time where some of this stuff rolls out. So if you're trying to kind of have a trend analysis of how my jobs are going over time, that stuff starts going away. And then also too, is a lot of folks that we work with are doing a lot of pipeline jobs, right? Where it could be, step one could be, first notebook. Step two could be a nested notebook, or maybe you're using Airflow to orchestrate your jobs, right? This tool, this interface is great for showing single jobs, clusters, but where it falls is if you want to start getting a little bit more granular. But good first step, right? So generally speaking, good first place to start. For the folks that are writing your Spark code, this should look very familiar. I hope so. I hope you're using the Spark UI. And so Spark UI has been around, even before Databricks, right, as a service, but it's essentially kind of the inner workings of Spark UI, right, or of Spark. I'm sorry. So looking at, starting at jobs, being able to drill into the stages, how long are things taking, where's some of the bottlenecks? This is a very, very powerful, and in fact, I would say a lot of folks, I'm sure for the Spark savvy folks, this is kind of your go-to in terms of understanding what was going on with your Spark job. It does a very, very good job of giving you all the details that you need with a Spark lens, right? So it's going to be talking about Spark context related things like, Spark job, Spark stage, a Spark task, executors, drivers, so on and so forth. It's great at that. But if you need to zoom out and you need to start thinking, okay, it's great that I'm getting all these metrics from a Spark lens, but what if I want to start looking at things on the host level? Hey, how did this affect, this particular executor? What was the interaction with some of the host metrics, like the overall disk space on that, on that node, network related issues? That's where this is not the best use case to be using Spark. But again, when you're thinking of very Spark related information, Spark UI, way to go. Spark logs. This is your, very granular, fine-grained insights into hey, I want to get into the nitty-gritty. I want to start looking and seeing, going into the logs. And a lot of times when things get very hairy, you need to get to the logs. The Databricks UI can only tell you so much. The Spark UI can only tell you so much. Sometimes you just really need to get your hands dirty and get into the logs, right? So your driver logs, the worker logs. Databricks does a great job of providing some of these details for folks, right? So the folks that really want to get into the weeds, you do have the logs. Now, a couple of things that I've ran into, some concerns that I've had with folks that will want to get even deeper into the logs is, well, one, you need to have an overall understanding of how the Spark inner working, Spark works, to kind of really understand what's being logged and what's being shown. And so there's that. So there's a level of expertise to really get in here, right? So maybe somebody who's just starting out with Spark, this might not make sense to them. Maybe over time they will. So there is a level of expertise. There's also things you need to consider in terms of just, we've already talked about 3 out of the box tools right now. Now it's starting to kind of get a little bit of a headache, right? In terms of correlating, okay, I'm seeing this in the logs. Let me check out the timestamp. How does that relate to Spark UI? How does that relate to overall Databricks, the Databricks console? And so it's starting to get a little bit tricky, but like these are great tools, guys. Like I'm sure, especially for the folks that are very, very, in detail and working, very, day to day with Spark and Databricks. You guys are probably using these tools today, and it could be good, good for you, or we could have a better experience for you guys. So everything that we've talked about so far is I wanted to start tracking a couple of things to just be mindful of as we go through this journey of observability from a Databricks standpoint. So OOB means out of the box. It's just my short term, my acronym for that. But really what we've shown so far is if you're looking for things in terms of just overall the status of your Spark jobs, everything that we've covered here so far is addresses this, right? Databricks console, Spark UI, logs, right? If you want to understand things in terms of resource usage, but talking Spark language, using that Spark lens, like talking about executors and drivers and tasks and all that good stuff, you have that covered here. Getting down into the nitty gritty, logs, tell all. Logs don't lie, right? You have the ability to do that as well. For the most part, all this stuff is very easy to use modern interface. Databricks wouldn't be so popular as it is today if it was very hardcore developer centric. You could potentially have some folks that maybe semi-junior and kind of get the lay of the land with the tools that you have today. Finally, plug and play ready, right? Once you whether you're doing this from Azure, whether you're doing this from AWS, and now with GCP, with the recent announcement, this stuff really is plug and play ready. Like when you're ready to start submitting Spark workloads, it's really easy for you to do this. And on top of having some, really nifty out of the box monitoring solutions to give you that observability up to a point. Where things are lacking would be things in terms of like network metrics, host level metrics, right? Maybe I really want to get in on that worker type, that driver type, and really just get, like, did I use all the resources on this particular node, right? Spark UI can tell you everything in the context of Spark, but you don't have that correlation of what's going on from a host level metrics perspective. On top of that, everything I've shown here so far, there is a level of experience for you to kind of just correlate all this information and say, hey, is there something that I can do, in my code to make my code run better? Like, was there data skew? Was there, shuffle imbalance? Whatever it is, there's still, dependency on your developers to figure that out. And then also too, just from a configuration standpoint, infrastructure related. Should I be using auto scaling? Should I be, am I actually using all the resources on the instance types that I'm selecting? You're still not getting those level of, you get some of it, but it's not really, it's not proactively telling you what you need to do. Okay. So from an out of box perspective, that's what you have. Luckily, you also, as a Databricks customer, as it stands today, at least with Azure and AWS, and not sure about GCP. It was I didn't do the research on that, but you do have other third-party tools like a tool called Ganglia. Now, Ganglia is the reason why I have it in here is because literally it's just a checkbox that you can add there, and it gives you some more deeper metrics, right? So I thought it would be good to just kind of just give you, just straight up, hey, what does Wikipedia tell me about Ganglia, right? Ganglia is a scalable distributed monitoring tool, right, for monitoring high performance computer systems, grids, clusters, networks. Grew out of Berkeley, University of California. Started out in 2001. So these guys have been in the game from a distributed system standpoint, monitoring standpoint for some time now, right? And it warrants itself from a use case perspective that, hey, this could be something that can give us maybe some of the metrics that we're missing, right? And we'll go over it here shortly. And so, Ganglia, again, really, really good tool. All you got to do is just, configure Ganglia for your particular job cluster. And then you're off to the races. And so what do you get out of it? So there's a couple of things you get. So you've got cluster level metrics. So, I wasn't, you're not necessarily getting this from like the host level, but aggregated up to the cluster, right? In terms of, what is your CPU load? What is your memory load? Your network load, your cluster CPU load, this stuff is important, right? Because while Databricks is going to abstract away some of the complexities in terms of how it interacts with the host level, sometimes you need to really get into the details to really understand. Some of the things that you may use this for is for just understanding, hey, am I at like the instance types that I'm using, am I at 50% CPU utilization? Okay, if you are, maybe you're spending too much on the instance types. Maybe you need something with lower compute, same vice versa from a memory perspective, right? Now you start getting levels, details of just understanding from an infrastructure standpoint, am I sizing things correctly? Ganglia also provides a very nice interface for looking at the node level. So if you want to go into a specific node, maybe there was some, imbalances on the node that got spun up in, Azure, AWS, maybe it had some disk issues. Hey, nobody's perfect, right? But, if it is impacting your job, you want to know about that, right? And so Ganglia is very, very good for giving you those host level metrics to get you a more, fully compatible view of what's going on with my job, right? And so, Ganglia is a very, very good source. Now, as you guys are seeing these screens, one of the things that kind of jumps out to me when I first started using Ganglia is that it's kind of old school. Not gonna lie, if you look at these screens, I apologize, they're a little bit blurry. I took a screenshot, but they're a little bit dated, but hey, there's still good information there. But one of the things, obviously from additional insights with Ganglia, hey, host level metrics. That's like, for me, it's a great, dimension of understanding from an observability standpoint overall, like how did this job run? How can I optimize? Am I spending too much money on resources, et cetera, and so forth? There's other things that Ganglia does, but like, the biggest thing for me is just giving a level of insights on CPU consumption on the node or the cluster level, memory consumption on the node or aggregated up to the cluster level, disk usage. Hey, did I have some disk issues? Persisting this to local disk, maybe I shouldn't be, And so being able to have some level of visibility into there, ends up actually being a good thing, as well as network IO. And so this one, I've worked with a few customers, not naming, CloudStack, but sometimes there could be network related issues, right? Depending on the region that you're in, depending on, if you're using, whatever it may be, right? Network issues for the most part, one of the reasons why you pay like a Databricks or an Azure or an AWS is you are abstracting away the concerns and they're supposed to be managing this, but you know what? Nobody's perfect. Sometimes there could be some network issues. And if there is, you want to know about it, right? And so, that's also a very nice, metric that we include, or that the Ganglia includes into their tools. Now, what you can do with these insights. Sorry, this is a kind of a rehash what I just talked about, but understand if nodes are properly allocated. Being able to confidently say, hey, I've selected the right instance types decision, based on the requested resource. And I wanted to highlight there is that, like, we are still in the mindset of, when I asked, when I set up in my Spark submit that I wanted 16 gigs, Ganglia is going to show me, how did that 16 gigs get allocated on the nodes, right? And so we can base that and say, did that, was I setting up my 16 gig executors on instance types that have 64 gigs? You can see the wastage right there, right? So, it helps you guide, hey, I should be picking the right instance types based on, whether the requested resources are for my job. It also helps from a auto scaling standpoint, right? So, there is a cost, that with auto scaling that you have to keep in mind that, like, it's a great feature when you need to understand, or you don't know what your max is, or maybe you have some varying, data volumes, and you don't want to just max it out because, that could affect performance, right? And so it would be good to know, like, hey, what are my patterns from that standpoint? Even on the min side, one thing to keep in mind is I've seen folks where they would set their min number of nodes, down to like the default, like 2, right? And no harm, no foul there. But as we're looking at some of these characteristics in tools like Ganglia, you'll see that it'll start with 2. Databricks will understand, hey, 2 is not enough. We need to bring this up to 5. We need to bring this up to 10. The challenge here is that when it's making these, making these decisions in real time, there still is a request for the infrastructure to say, hey, I need 5 additional nodes. I need 10 additional nodes. And at that point, you're kind of at the mercy of the cloud vendor to, make sure that they do it in a timely fashion, et cetera, and so forth, right? So if we are observing this stuff over time and we say, hey, 2, it always starts with 2, but then it ends up always like, starting at 5 or 10 or whatever it is. It would be good to know, so you can set that min, a little bit higher, so that way you're not wasting time and you're getting all the allocated resources that you need for your job, right out the gate. And obviously there's performance impact on that. And so, yeah, it would be good to know that kind of stuff. You can get that with tools like Ganglia. And then obviously we talked about this before, understanding network IO related issues. Hey, nobody's, there could be, issues from the stacks itself. And, if there are, we're waiting for data, or just read write is just really slow based on, the inputs or the outputs that I'm reading, you want to know that kind of stuff. And Ganglia can shed some light into that. Now, some of the things, we've talked about Ganglia. It's, very, very great tool, but there are some limitations that you need to be aware of. And for folks that are gone down this path, you probably are aware of some of these. One thing is Ganglia is a snapshot-based tool. It's like a point-in-time type of tool. And so when you're looking at Ganglia, it has, nice, those screenshots in terms of showing cluster level metrics, node level metrics, but they're going to be like point in time, right? If you want to drill in, or like get more granular, maybe like a few minutes snapshots is not enough. You don't really have that. Now, some of the stuff's configurable, but it is, I do want to, just caveat it out there that these are snapshot based. So like, you need to be mindful of how you're using Ganglia. The outputs in itself, they are JPEG outputs, and so like, if you wanted to like, have an ability to kind of like click on a particular data point, get a better understanding of, how this relates. If I click on a cluster and I see like a spike, you don't have the drill down capabilities, because these are literally just JPEG outputs, right? And so, there's some limiting factors from that standpoint, right? So while it's great from a visibility standpoint, if you want to get even more granular, you are limited in your options there. Also too is like, hey, the data that gets stored with Ganglia, hey, it does have a shelf life, right? Data does get removed over time. So if you're doing trend analysis over jobs over, a couple of months, when that job's gone, it's gone, and you don't have that data, right? And so if that's important to you, a consideration to have. And then again, this is probably the bigger one, it's just another tool to correlate all the information that you have across all the multiple tools that you're probably already using today, right? Databricks console, logs, Spark UI, Ganglia. There's nothing here that says, hey, at this particular point in time, here's how all the data matches across all of these, observability tools. You don't have that, right? So it's another tool to correlate. For some folks, no problem, but for most folks, that could be a challenge, and that can sometimes add even more cycles that you were unexpecting, right? So last point that I have for Ganglia is that if you look at some of the support for Ganglia, is that Ganglia is a great tool developed out of Berkeley, came out, hit the scene around early 2001, I believe, right? But if you look at open source monitoring websites like GitHub. GitHub, I'm sure, hopefully you guys know what GitHub is, but like, if you look at like Ganglia and you look at, say, for example, I want to know, how the contributions have been over time, right? There are some spikes here and there, but you can see that, support commits are starting to kind of wane, right? A lot of it is because it's based on, older technology. It's harder to kind of retrofit with what's going on. It's, again, great tool, but you can see that, the committers are kind of waning, right? Is that a good or bad thing? I'll leave that up to you to make that decision. But it is something to keep in mind when you're thinking about the longevity of of Ganglia. How much longer is it going to be supported? The other thing to keep in mind too is when you think of observability platforms, we've been talking about we've been talking about Ganglia a lot is because, to be quite honest with you, it's included in Databricks, right? So why not use that? There are a plethora of other open source monitoring tools out here, but I would say probably the big elephant in the room right now, maybe or maybe not, you're familiar with it, is a tool called Prometheus. And Prometheus, born out of SoundCloud, it's a different architecture, right? It's really starting to make reigns in the Kubernetes community. I'll stop there. It's it is an alternative that you can use. If I were to do a comparison between the committers of Ganglia versus like an open source tool like Prometheus, you can see here there is a lot of traction here. A lot of a lot of interesting things that are going out of here. People are starting to really use Prometheus as a tool. Now, in full transparency, I wasn't planning on covering Prometheus. You can definitely do your homework, but it's something that a lot of folks are starting to really, take on. And if I would say from a pure popularity perspective, it looks like tools like a Prometheus are starting to really kind of gain traction, whereas tools like a Ganglia are kind of seen as a little bit outdated, and the future is questionable for open source monitoring tools like Ganglia. So going back to my matrix. Now we've talked about out of the box. Now let's add Ganglia in the mix, right? So Ganglia's real true focus is, at least in the context of Databricks, is really giving you those host level metrics, right? So it's not going to be speaking Spark terminology per se, right? So it's definitely not a modern interface. I guess that's open to interpretation. It's not for me, a modern interface. It is plug and play ready because, like I said, you can just go ahead and click it. It gives you network metrics, host level metrics, which is missing with the out of the box tools that you get with Databricks. And so, but it still doesn't give you some intelligence built in for proactively telling you what's wrong with your code, proactively telling you what's going on a configuration standpoint. So the way I would frame this is, because these both come with your Databricks instances, this is a better together story, right? I mean, if you were to where Ganglia is weak, the out of the box tools cover. Where the out of the box tools are missing some functionality, Ganglia covers that from that perspective. So it truly is a better together story. And maybe most of you folks are using this combination of tools. Okay, that's great. But we can do better, guys. We can definitely do better. And so now let's start talking about some other monitoring tools that you may or may not be interested, may not be privy to. If you're coming from the AWS camp, there's always Cloudwatch. And Cloudwatch, great tool, guys. I have nothing to knock on it. In fact, it's built in, cloud native. They have syncs that are available for you to connect in. You can do these nice, pretty, graphs. And so, this definitely is an option where you can kind of link into, some other various data sources, right? Maybe even some stuff that AWS is monitoring as well. And you can kind of correlate that information a little bit better into like a dashboard that may, kind of give you a little bit more insights, right? And so you do have that option. Azure has something very similar. I believe it's called log monitoring and analytics nowadays. I could be wrong. They do change things up there quite often, but concept's the same, guys. Like being able to show things from, if you are on the Azure stack, how can I go and correlate some of this information in terms of network, in terms of throughput, in terms of disk IO, in terms of my servers, so on and so forth. You do have this option. Now, some things that you do need to consider with cloud native tools is that, when you look at the most common dashboards, their primary audience is intended for classic web applications. What I mean by that is, like, you've got your database, you've got your Java or your .NET app, and you really kind of just want to get an understanding from that perspective. It's going to be very, very great for that. But as you guys know, from a Databricks perspective, things are a little bit challenging, right? I mean, you're working in a distributed system where there's a lot of dynamicism, right? In terms of the number of servers, the number, where the disk is coming from, even the disk storage is distributed, right? And so it can answer some questions, but it's not going to give you that full 100% end-to-end observability platform across modern data applications. What I mean by that is like your Databricks for, in this context, right? another thing to think about is, guys, this stuff it's semi plug and play ready, but it does require development integration. You do need to have somebody there to configure this stuff, understand it, correlate it, put it into nice, pretty graphs. That's going to make sense for your organization. So there is some custom development that's there. And so you do need to keep that in mind that, while some of this stuff, there are some great tutorials, both from an AWS and a Microsoft perspective that can help guide you there. But you are, at the end of the day, you are truly creating something semi-custom based on your wants, your needs. And so, this isn't plug and play ready. Like if you were to like just click a checkbox and to have Ganglia configured, right? It's not that simple. So there is some time and effort for that. Because of that, there's a cost to maintain, right? So you do need to have a team that's coming in here. Like this stuff changes left and right. You guys know this, right? Databricks releases something. Maybe they release a new technology. It's something now. Yet again, you need to build this into your observability platform, right? So there's always going to be a cost to maintain whenever you have some sort of custom, component, and it's something that you need to consider from that standpoint. And then finally, last but not least, depending on how important this is for you, but I would say the trend for a lot of customers is trying to avoid vendor lock-in because customers have been burned in the past. And so if you are using AWS CloudBreak, it's going to be bang on excellent for AWS native tools. Lacking from an Azure perspective. Same thing from Azure, right? Now, they are being more open in terms of bringing in some other, metrics and stuff like that from other cloud vendors. But you're really going to see these cloud native monitoring tools really excel on and also provide just extensibility from the tools that they obviously host themselves. And so do you really want to be in that? Some folks are okay with it. Some folks, that's not the overall strategy. So you got to keep that in mind when you think of cloud native tools. One other thing I forgot to mention here too is that when you are using a Cloudwatch, when you are using an Azure log monitoring and analytics, you are still paying for this. Now it's, depending on how much data that you're bringing in, there is a cost for that too. So this stuff isn't I wouldn't call it quote unquote open source where, hey, you're free to do whatever you want to it. There definitely is a cost to maintain or a cost for using Cloudwatch, Azure log monitoring and analytics. You have to do your kind of cost benefit analysis to see if that's even a route that you want to go, right? So one last thing I forgot to put in there, but yes, these services are not free. They're not free. If I were to spin up a Ganglia instance, you do have to pay for the stuff in addition to, building out custom solutions on these monitoring tools. It behooves me to not mention other third-party observability platform tools. So there's a lot out there. Datadog, I would say, is probably one of the more popular ones. And so if you're not familiar with Datadog, they are an observability platform, one of the leading ones that are out there. There's also a New Relic. Great tool. And the reason why they're so popular is because they do bring a lot of insights and nice, pretty graphs to really understand where the bottlenecks are, right? And so here I just went onto the Datadog website just to kind of give you guys kind of a visualization of how things look at from a Datadog perspective. And again, a lot of folks love Datadog because it is very simple. The installation is, somewhat simple. And it gains some metrics, it captures metrics and it presents it in a way that's just very easily consumable. So that way we can get to quicker mean time to resolution. Some things that you want to consider about something like a Datadog, like a New Relic is, yes, this is definitely an easier interface to work with. It's from a plug and play standpoint, it's very easy to get this stuff configured and you're off to the races, right? And it is pulling similar metrics as Ganglia, as Spark UI. But again, the community on these tools have done a good job of really correlating this information to really kind of get the insights, to faster, right? And they have nice, really pretty graphs as well. The one thing you do also got to keep in mind though is with these tools like a Datadog, like a New Relic, they are very classical APM. Classical is probably a strong word, but it's they're very, very strong in your e-commerce sites, web tiered applications, and so they can give you their their reports and their dashboards that give like the biggest business value are going to be those type of use cases, where when you're looking at distributed applications like Datadog, it can definitely help, but it's not giving you 100%. It's not speaking Spark context, Spark language as much as they would like to. But admittedly, hey, their forte is, your classical kind of web applications. And if we want to use, get that APM kind of feedback, it's going to be in that lens, and that it may not answer all the questions that you're looking for in terms of optimizing your Spark jobs. And it can be expensive, depending on your model with Datadog. Makes sense if you're an existing Datadog customer, you can go ahead and add it to it. But if you're thinking about doing this net new, I would definitely kind of look at the pros and cons out there, because yes, I've shown stuff that comes out of the box. I've shown some stuff that maybe you can do with cloud native. You got to do a cost analysis to really understand, hey, is this going to be enough for me? My recommendation is, if you are a Datadog customer or you're going to be using Datadog for other things outside of distributed applications like a Databricks, then this can be something that's very useful for you.
Hey, just a quick question. Quick reminder for the audience is, if you do have any questions, feel free to pop them into the chat box. Type in your question, and then we'll be able to get it at the end of the session. If you are watching on demand, feel free to drop us a note at hello@unraveldata.com or chris@unraveldata.com. That will go directly to Chris, directly to this person here. So I thought I'd kind of interject, because
thank you.
You're kind of zone, and the context is absolutely fantastic. But yeah, feel free to flip back to screen share now.
Awesome, great. Thanks, Quack. Can you still see my screen?
Yeah, if you want to click on screen share, you'll be able to flip back to your screen.
Oh, wait a second. Oh, you, okay. This is how you know it's live, guys.
Yes.
We have to do this stuff. So hold on one second here. All right. I didn't even know my video was on, so hopefully I wasn't doing anything.
That's why I had to really interrupt you and say, oops.
It's okay. All right. So you also gave me a chance to look at the time, and okay, I got to speed this up a little bit. So, kind of going back to this whole feature matrix, right? Now we talked about out of the box. We talked about Ganglia. We introduced cloud native, right? And again, this take this for what it's worth, but this is my observations, right? Cloud native APM is very, very good at giving you, can give you good stuff from a status metrics of a particular job. When it comes to Spark context, I would this should still be a checkbox. Okay, sorry guys, but you can bring that into Spark UI, into some of your other cloud native tech, and show that. But again, customization, right? Where this stuff fails is it's plug and play ready to an extent that there still is customizations. You gotta still connect to the sinks to bring in this data. You gotta ingest the logs. You gotta create the visualizations. You gotta create the dashboards that are gonna be meaning for you. And so with that, I have to put this as a red X, because the stuff isn't as plug and play ready as out of box or Ganglia. You can connect to network metrics and host metric. Again, this is going to be based on what AWS, Azure, and GCP give you. But again, there's that's plug and play ready. You got to bring the stuff in. It's up to you to bring it in, correlate it, make sure that it matches. It's so you got to keep that in mind. And then all three of these tools still are not giving us like proactive code level insights, optimizations, as well as things from a configuration level. So, we've talked about three, kind of scenarios, but, let me ask you guys this. What if there was a tool that did provide insights at the job level, at the host level, at the Spark level? What if there was a tool that actually had some proactive intelligence to not only just show you things from an observability standpoint, but then also give you some proactive insights and recommendations to potentially make your job better? What if there was a tool that was very easy to use and had a very modern interface, correlating all this information that we've kind of talked about so far, in a very plug and play ready state, right? And last but not least, what if there was a tool that was very cloud agnostic, right? Whether It might be GCP today, but maybe you move that to Azure. Maybe you go, to AWS, whatever it is, right? So kind of keeping with the theme, I feel like that's the big trend with customers right now, being, cloud agnostic. What if there was a tool that checked all that boxes? And what do you know? There is a tool, Unravel, that can check all these boxes. But you know what? I'm not going to let a slide show you that. I want to show you guys the proof is in the pudding here, guys. So, Quack, you can still see my screen, right?
I can, yes.
Okay. So, guys, look, if you want to have a more in-depth demo, I definitely would encourage you to look at some of the other demos that I've done. But, I wanted to at least show you the highlights from an observability standpoint. So, Unravel as a tool is able to monitor AWS Databricks, Azure Databricks, GCP Databricks was just released, guys. So we'll get there. We're not there yet, but we will. But being able to understand all your jobs. So this would be something that the Databricks UI can give you, and then some. Like we're able to persist this information. So whether it's a month ago, 2 months ago, 3 months ago, we're capturing all this information. We also have some additional things in terms of like read and write, the workspace it's in, the instance, even more approximated costs. This is great, especially if you're just trying to get an understanding of, how much this stuff is costing. You can use, the cost management section in AWS, but it's going to be, drilled up into the infrastructure level, right? And so these are just like from an overall standpoint, it gives you, a great feel of just, that high level overview of how your jobs, how your, whether they're interactive, whether they're job clusters, we have that. We also have a view for folks that are looking and just tracking pipelines over time, whether you're using the Databricks UI or the CLI to schedule your jobs. Maybe you're using Airflow, maybe you're using Azure Data Factory, being able to kind of just understand trends on, hey, how much is this costing me, over the life of the runs, how, you've got this nice pretty graphs, so these squiggly graphs that kind of just show you how, things are going up and down. Like, these are some of the like things that just come easily, plug and play ready. I can start really doing damage with some of the high level visibility from that standpoint. But let's not stop there. Let's go into the Databricks jobs, right? And so here's an example where it's just a regular Scala, application from a job cluster. And just from an overall observability standpoint, I can look at things in terms of, hey, in my stage types, input, output, processing, where's most of my time being spent? I want to drill in, how much time was spent from that standpoint? What are some of the insights that I can get? So here we're getting into more of that proactive insights and recommendations from a timing standpoint of like where we're seeing a lot of time actually being spun up, right? Where was garbage collection time? Was that an issue? IO, like were we spending a lot of time doing a lot of shuffling, whether it's on the read or the write? All this stuff is great from an observability standpoint. On the left-hand side, Spark UI, right? Being able to look at things from a job-centric view, being able to drill in from a stage, going into, okay, now we're looking at all the tasks. Out of the 100 tasks, how did that break down in terms of the timing spent? How did that look from a timeline perspective? Did I have any data skew? This distribution chart will tell me, how data and time was distributed over the life of the application. How does this look from a visualization of all the tasks that are being submitted? Okay, great. Let's even open it up into more on the code side. Let's just say, hey, I wasn't expecting this particular line of code to run for 3 minutes or this particular stage to run for 3 minutes and 41 seconds. I don't, I may have like multiple files and there are thousands of lines of code. I don't even know where that is. We can just shortcut to you and just say, here you go, guys. This is the one. This is the one that was taking the longest time. Now you've got that code correlation. Now you can start really understanding, okay, maybe I shouldn't be using this for each loop. Maybe there's another way that I could be parsing through this data. Maybe it's another, group by key that I could use, Possibilities are endless here, but now you've got that correlation. Now let's just say you're running your job, and now you're from an infrastructure perspective, you're trying to understand, did I set up my job correctly, right? Did I set up my instance types correctly? Sorry, let me finish my talk track on this one. So we do have, again, those proactive insights and recommendations in terms of, from a Spark submit level, what can you do here? In this particular case, I asked for 5 gigs per executor. I didn't need 5 gigs. I only needed a gig, right? And so those are the things that we're going to proactively tell you, right? Really speed up that mean time to resolution, really speed up so that way you're optimizing your jobs, as soon as you submit the job, as opposed to where most customers are doing a trial and error thing. Here's another example where we look at some of the parameters in your Databricks job, and if there's things that we can do from an instance type recommendation, right? Hey, maybe I was a novice. I submitted this job asking for 256 gigs of memory, 64 cores, $4.87 an hour. Very, very heavy, right? I didn't even need that because it wasn't even that heavy of a Spark run. And so here's some proactive recommendations that we say, hey, next time you do this, use this DS3 V2 instead of these D64s, because hey, you're saving $17.86 an hour, right? Lots of customers have jobs that are running to 8 hours, 16 hours. So I've seen one that's 24 hours. So, I mean, if you could even drop the price per hour from that standpoint times however many times that run, obviously there's a return on investment from there right out the gate. Have that recommendation there. Very, very powerful for customers. Let's say your job fails, it's a challenge, right? We talked about correlating all this information. Usually what a Databricks developer will do is they'll go into the logs, they'll look into Spark UI, they'll look into, the Databricks console, get some information. You know what? Let's cut that to the chase. Let's get all that information for you guys. Here's your errors, across the life of the application, whether it was on the driver log, the worker log. Here's the things that would have caused some errors, right? We can give you the logs itself, a subset of logs, by the way. But if you want to kind of know what the before and after was before we started having issues, we can provide that information here, right? So here, look, we had an error here, but what was happening before, what was happening after? You've got that level of detail for you. If you just don't even want to be bothered and you want Unravel to tell you what happened in this particular job, we'll do some analysis for you. So again, that proactive nature of us being, hey, you know what? You had some issues with the driver. It just had whatever you were doing, just didn't have enough memory. This is the reason why, increase your driver memory size, and that would fix the problem here. So from a root cause analysis, you've got that going for you. Hey, let's zoom out. Let's now start talking about pipelines, right? And a lot of folks, I don't care about one job run. I care about a historical number of job runs. So how are things tracking from a duration standpoint, right? This is a simple pipeline here, but it's really showing this is a data factory job that, just running one job, it looks like it's every day, right? So how are things trending from a time perspective? How are things trending from an IO perspective? Is my IO trending positive? Is it jumping all over the place? How am I trending by cost? All very, very good insights. So that way you can, quickly understand usage pattern, usage trends, and really get to it. Last but not least, I've got a sneak peek for you guys. My engineering group is working on this, so this is definitely, a sneak peek. But we do have a new UI out, and it's the features and functionality in terms of Databricks. We do have same insights in terms of from an observability standpoint. How much containers were being used, vCore, memory on a Spark level. Same analysis, right? In terms of that proactive, efficiency gains. Hey, we noticed there was a shuffle stage with load imbalance detected. Here are things you need to look at. Here's those cost-effective recommendations. Either from a driver or a worker, worker level, right? We've got that same Spark UI kind of details in terms of job stages. Which was my longest stages. You get all that good stuff and a nice new UI. And last but not least, we also have, visibility and insights down into that JVM level. So how much memory are my executors and drivers taking, right? This is speaking Spark language, right? And I can get to see that, over time, that, my executors are taking 14 gigs, 12 gigs, and I can see this visually, throughout the life of the application. All great stuff to make sure that, the next time I run this job, maybe 16 gigs should be my executor size because I never go over that, right? Host metrics. This is where we start getting into the Ganglia kind of discussion. And that's because we integrate with Ganglia, you know? I mean, it comes with the tool. Why not bring this information in? So what's going on from a host perspective in terms of the OS level memory, the CPU utilization, again, on the host. We're not talking executor. We're talking about the host itself. You know, we get that level of detail. What's going on with disk space? You know, what's my disk free, you know, throughout the life of all of my instance types here, and obviously it's all equal here, right? Or from a network standpoint, you know, am I getting all my network packets in, my network packets out? And so, like, if there are like delays from reading data from DBFS or wherever it's from, I can clearly start correlating this. The best thing about this, guys, is that everything that I had talked about, minus Databricks, minus the cloud native tools, all this information is input for us, and we correlate this information for you. So from an observability standpoint, you know exactly, you know, you have best of both worlds. You're able to see everything, correlate everything. Everything is, as you see here, is, you know, matches with the same time down here. And so I can get that from an observability standpoint with the added feature, our bread and butter, having some intelligence built in where we do the analysis for you and point out some things that you can actually, you know, get in front of so that way you can have better, faster performing jobs. You know, the world is yours with Unravel. No, not really, but lots of great things from an observability standpoint. I know I'm, you know, running out of time here, but hopefully this, guys, you know, kind of gives you an overview of what's out there, what you should be using out of the box. If you're ready to take it to the next level and really speed up, you know, time to resolution, make sure that you're cost optimizing all of the jobs that you're running in your Databricks environment, and overall, you know, make sure that all the projects that you're running in your Databricks environments are successful and not wasting any money. Unravel is the tool for you. With that, Quack.
Questions. So we've got a number of questions here. We probably have time for one or two.
Okay.
If you are watching and you would like to ask a question, feel free to submit them through the player, and we'll be able to get to them on demand. So first question: are we in AWS or Azure on the marketplace?
So good question, and we're actually in both. So if you want to try, you know, AWS, or you want to try us, we do have a marketplace option that you can go in there. We also, for folks that may just want to just try this, you know, and not even spin anything up in their whole environment, all we require is just outbound TLS connection to our instance. But we do have a SaaS option, so that's the quickest thing. So if you want to start seeing some of these insights, not take my word for it, I stand by the product. I would definitely, it behooves you to try this, and SaaS is a great option for you to try this in your workloads.
Fantastic. Are we planning to integrate with any other monitoring tools? I know you mentioned Ganglia.
Great question. Yeah. So there's a reason why I put Prometheus in there. And this is in development, guys, but you know, there are some really, really great community supported monitoring tools out there that we can actually use and augment. And so Prometheus is a very viable candidate where we're starting to roll out with customers. Now, granted, as the industry moves to not just EC2s and VMs and start moving towards this containerized, Prometheus is going to provide some tremendous value there. And so engineering may slap me for saying this, but we're planning for it.
Fantastic. Right, I think that's the time we have today for this webinar session. Just a reminder, if you do have any more questions, submit them and we'll be able to answer them on email reply. If you are watching on demand and would like to ask a question, feel free to email us at hello@unraveldata.com or chris@unraveldata.com. Thank you very much,
Yes.
Chris,
so much.
for your time today.
Yeah, it was a pleasure.
Guys think by dropping some comments or feedback in the comment section. Give us a rating, give us 5 stars if you really enjoyed it.
I would love that if you could. We have a little competition going on here, so.
And we hope to
not really.
Future webinar. Thanks, Chris.
Great. Thanks, folks.
Thank you. Bye.
Bye for now.